Today we are going to be talking about inverse functions. Okay, so we know that a function takes an input and returns an output. The input is the domain, and the output is the range. Domain is all the real numbers that can go into a function, and the range is all the possible values a function can take on. So, a function is basically the mapping from domain to range. The question is there a way to go back from the range to the domain? That's where inverse functions come in. Okay, so let's do an example. Let's take the function f(x) is equal to 2x minus 6, and let's have x equal 5. That's the domain. Now let's plug things in and do some algebra. So we do 2 times 5 in place of the x minus 6, which equals 4. That's the range. The function took us from 5 to 4. Now the question is there a way to go back from 4 to 5? Well, the answer is yes, there is, and it's called an inverse function. What we are going to do is solve the function the other way around, or backwards. Fx can be written as y, so we are going to solve for x in terms of y. So we want x to be on its own. So we have y is equal to 2x minus 6. So to get x on its own, we add 6 to each side, which equals y plus 6 is equal to 2x. Divide everything by 2, and you get 1/2 y plus 3 is equal to x. So our inverse function is going to be x is equal to 1/2 y plus 3. The inverse function of fx equals 2x minus 6 was found to be x equals 1/2 y plus 3, which can be rewritten as f to the negative 1x is equal to 1/2 x plus 3. That was exactly what we were trying to find. All we did was start with the original function, y equals 2x minus 6, solve for y in terms of x with some algebra. To find the inverse, we took the original function and solved for x in terms of y. Okay, so let's check just to make sure we did it right. Our function took us from 5 to 4, so our inverse function should take us from 4 back to 5. Our inverse function was f negative 1x equals 1/2 x plus 3. In this case, the x is going to equal 4. So we solve it by plugging in x. So 1/2 4 plus 3, which equals 5, which proves that we did it right. Yay! Now, let's finish up by talking about graphing functions and inverse functions. So we have our function, fx equals 2x minus 6, and we have our inverse function, f to the negative 1x equals 1/2 x plus 3. Well, to graph these, we start off by drawing a coordinate plane. To graph fx equals 2x minus 6, we go down 6, and then for slope is rise over 1, so we go up 2 and over 1. So our line for the function will look something like this. To graph the inverse function, we go up 3, and then rise 1, run 2 for the slope. So our line for the inverse function will look something like this, and they'll intersect at this point here. Now, what can we see about the relationship between the two? To better understand, let's draw the line y is equal to x. Let's draw it as a dotted line. We can see that the function and the inverse function are reflected about the line y equals x. This is because a function takes us from the x to the y. Then when we switch it, we go from the y to the x. That's what makes it an inverse function. All in all, an inverse function is a function that reverses another function. If a function is applied to an input x and gives a result of y, then applying its inverse function to y gives the result of x.